Base program here to teach you some new stuff in Python. Today I'll continue my sequence of videos that is called Python tutorial. So today I'll teach you how to make a better model of machine learning, and in yesterday's video I'll show you how to introduce machine learning, and I guess that code was actually working perfectly with 100% of, like, actually not 100% in relation to all things, but actually, and the prediction that I've made was 100% of currency. So that model was working, but it was so simple. You couldn't use that style in real life models. So today I've brought a better code to show you how to use it in real life. So I made with the same base libraries, all using scikit-learn and pandas numpy just for helping me for another activities with data analysis and this other data science subjects. And especially this code is really working. I made a cancer prediction one that I already made a video about it, but it wasn't so good as this one because the other one wasn't applicable to the reality, but this one actually is. So I use the two base libraries, the scikit-learn support vector machine, support vector classification, the scikit-learn matrix, and I use the dataset that's already given by scikit-learn. I didn't use grid search to try to make it, but it wasn't working, and I use it to train test split. That's the fundamental thing, the base for you making a grid model with train and test equally separated for grid. I'll show you better. And another metrics that I use is classification report and confusion metrics for printing data, some types of data organization. I made with this, and pandas and numpy for data analysis. So we'll start my code on A. So I'll show you firstly the base. You will need a variable with a loop breast cancer that is still a library that I have important, and we will continue using model SVC that you can see here. So for defining an X matrix and Y vector, we're going to use df cancer and df target. The cancer will be having the data, all the information about the cancer, and the target will have the numbers if the cancer is malign or the cancer is benign. So it's separated like this in data frames of pandas. So it's like this. So for getting, I explain this down part for it because I use another metrics. So for the train test split, we use the train and the test. We have it 4 variables: the weight test and the weight train, the x train, the x test. These 4 variables are divided for getting a better results in your testing, right? So firstly, for the train test split, get the first variable that is actually the cancer with the data, and we use it's just for separating, right? The first board is the X and the second board is the Y. So the first board will need be the X and the second one is the Y. This NP variable is just for getting a better organization of the data using NumPy, right? So this random state is just some technical D ports that it's really hard to explain right now. So I'll bring some more complex videos in future times, and I can explain it again. So, and to size, use a number from 0.99 to 0.01. Yes, it is for separating from 99% to 1% of the data we're gonna test, right? So actually we're gonna 80% of the data we're gonna train. So 80% of the data that I received is about 600 test patients, 600 patients. We're gonna This is the total rate. So we're gonna 80% of it we're gonna train. We're gonna insert in the brain of the neural network of a program. It's going to learn, and 20% of the total we're going to use for the model predicting what is it is. So we already have the answers. So it's called supervised learning, right? And by here for explaining more, I will you subscribe to the channel. If you like it, comment down below, hit the thumbs up, and please watch me down my later videos that I'll make and the videos that I already made, and I'll try to bring videos all weeks. So I will put in end screens, cards where you get in my old videos, and I hope you like all this. So please hit the thumbs up, subscribe, and comment things that you like and you didn't like for getting better new content. So let's go. So we get this 4 variables already set with train to split. So we're gonna use a model fit to fit data, right? So we already put the variables inside the brain of a machine. So I already made my PM, PM1, PD, 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 where I like to put this type of variables. So actually using model predict, we're gonna use the Yax test for having a little bit of knowing, but we won't have this now. We will just have classification, reporting, confusion matrix after it. So we have the accuracy score of our prediction of the tests. So yes, we're gonna have this too. Let me see. But there's something in this more complex board. We don't use accuracy score, right? But if you don't, it's not obligation to use classification, reporting, confusion matrix. Your model will have the same accuracy, but it's more organized as you see this. And the model prediction of a patient that is actually going to have it's going to have need right here in the last print. So let me show what I've made. I've put a P as a patient. So if you want to know any patient, put a number 1 to 500 and something to know what the diagnostic of the patients. So the program will tell you the diagnostic that it got, and it will say if it's right or wrong. And if it's melanoma benign, not truly, but maybe wrongly, but it's know if it's right or wrong. It will show you if it's right or wrong, the analysis that it made. So you have a little bit of sure if there's right or there's wrong, right? So you can make this analysis. So the accuracy score just to make then just this FL's differentiation. So I had this speed variable to have this 100% assured, just for the model getting like 0, 10, 0, 100, sorry. So at this first variable here is equals 0, that will be malign, and if it's benign, it's 0, 1, right? It's binary codes that we're gonna return. So I put this malign and benign just for being better to see what is it. So in the second one, I put if the PD3 variable is equals 100 as 100% of sure, because if it will be 100 or 0%. So if it's 100, prediction will be right, and if it's not 100, alright, it's 0%. The only 2 possibilities will be wrong. So you already made all this analysis, and I forget to see this board here. This spot is actually for you getting this number here and searching on the data sets that we have for getting these variables and this less analysis here to predict where it is. So let's start. Oh, I'm sorry, we're not gonna start now because we're gonna, like, say this classification report here. It's saying it's comparing the PM, that is the prediction, to the test. It's gonna compare the results. And the last one too, but it's the classification report will see everything, every method, and the confusion matrix will say everything, like an average. So let's start. Let's load them because it's a little bit heavy. So put the patient number. I'll put 400. So macro average, weighted average. So you can see here our model has 95% of sure. And before you get in this number here that I've got 0.20, you will need test for having the best results. And this one, the best result that I got with a sufficient number of tests, because you don't, it's a little bit bad you put in one type of, like 1% of test, because it's a shorty one, so actually it's not the greatest possible. So 20 was the best number I found in the middle of this, so I highly recommend you put in 20% of the model of training, right? No, testing. Training is 80%. The most important would be training. So the analysis that we got was right. So 400, patient 400 has a malign cell, malign cancer cell, and the program was really right. So we could make almost a perfect one. This machine learning can be fitted on the market, in a real market. So huge hospitals can actually use this code for saving lives. And I'm kidding. You just need the metrics that I have in this data set. I'm not medic, I'm coder, I'm in aerospace engineering, and I'm not expert in medicine. I just like to code and make calculus. So if you want to make this, use this library if you don't know anything about it. And if you have a real data set and you're a real medic, you actually can use it. So thanks for watching my video. I hope it helped you in this tutorial. I don't know if it's shorter or the less one, I don't know, but I'm just explaining how to make a better machine learning model for you. Results being better, your projects being better, and you can advance in your data science career and your machine learning engineering career. So thanks for watching. I'll bring some new videos next week. I'll try to bring 2 videos weekly. So thanks for watching, and goodbye. Don't forget to subscribe to my channel.